Creating sparks with carbon rods was just the beginning. Throughout the entire 19th century, scientists experimented with ever-increasing voltages and discovered that they can create longer and longer sparks in longer tubes. And they didn't have to use carbon as electrodes. They used different types of metals. The tube shown here, invented in the mid-1800s, was special because it had almost all of the air sucked out of it with a vacuum pump. And the man who invented it, Heinrich Geissler, discovered by pumping out most of the air and putting a very high voltage across the electrodes on either end of the tube, that the remaining air started to glow. He also discovered that by replacing the air with a pure gas such as neon or argon, that different colored lights could be created. This really was the first neon bulb ever invented, and it's the precursor to neon signs that we see in commercial use today. Now keep in mind that Geissler could only get the gases in these tubes to glow when they were under very low pressure. In other words, he used a vacuum pump to suck all of the air or most of the air out, and when he added new gases, he only added a small amount so that the pressure inside the tube was very low. And it was taken a step further by this man, a man named William Crookes, who with better pumps was able to produce even lower pressures. And in doing so, he discovered that the glow started to disappear, and the more he pumped the gas out, the darker the tube became, starting from the cathode, the negative electrode, and working its way to the positive electrode until there was no more glow at all. But he did notice something very interesting. He noticed that even though there was no gas glowing in the tube, the very end of the tube glowed, which indicated to him that something was striking the end of the glass tube opposite from the cathode. It became apparent to Crookes that some sort of a beam was being emitted from the cathode, the negative electrode at the far end of the tube seen here, and was being attracted to the anode, the positive electrode. And the beam was picking up so much speed that it went right past the positive electrode and struck the glass wall, making it glow. In this picture, we see that a cross was attached to the positive electrode, and the beams actually cast a shadow at the end of the glass tube. The sharp edges of the shadow indicate that the beam is traveling in a straight line. Throughout the latter part of the 19th century, several major refinements were made to the Crookes tube. Shown here, the anode was moved closer to the cathode, and it included a hole which allowed the cathode rays to pass right through it, striking the glass on the right-hand side. Now, because the end of the tube was coated with a fluorescent substance, a very intense small bright spot appeared right where the cathode rays struck the end of the tube. It was very small because it was focused by the hole in the anode. So now, even though the beam itself was invisible, its location could be determined precisely by determining where the bright spot was located at the end of the tube. And it was using equipment like this that J.J. Thomson did his experiments. And one of the first experiments he did was to confirm that the beam was negatively charged. As you can see here, Thomson placed negative and positive electrodes, positive on top and negative on the bottom of the glass cathode ray tube. And when he turned on the voltage on the electrodes, the beam deflected up towards the positive electrode. And since he knew that opposite charges attracted, he was certain that the beam was negative. But this was just the beginning. Thomson spent years measuring how much the beam deflected as he changed the voltage across the top and bottom electrodes. He also experimented with different intensities of the beam, and using new information discovered by scientists named Faraday and Maxwell about the relationship between magnetism and electricity, Thomson concluded that the negative charges were being carried by tiny little particles he called electrons that were embedded inside the atom.